So what we're going to do is we're going to look at all of the stretches, compressions that we have done in transformations and look how they affect our sine and cosine graphs. In fact, we're going to look at how they change the characteristics of our sine and cosine graphs. So the first thing that we're going to do above is we're going to write out a sine or cos b x minus c plus d. So A, B, C, and D are all transformations. Just a little review of transformations. Does it make sense that your A does a vertical stretch or a vertical compression? Your B does a horizontal stretch or a horizontal compression. Your C value is going to translate it left and right. And notice that the way that I wrote it, I already have it in the factored form. And your D value is going to translate it up or down. So right now, with these first ones, it just says determine the amplitude, but we're going to graph it as well. And these first ones are looking at what happens when you do a vertical stretch, so our A value. And we're going to remember that, I don't know if you have some sort of memorization device that helps you remember that the A value goes with amplitude. I don't know how you're going to do that, but somehow, if you can remember that your A value goes with your amplitude, then that'll be easy to remember. So what happens when we stretch this by 2/3? All of our Y values are going to get multiplied by 2/3. When we graph this, so here's part A, we're going to take our normal parent function, which when we graphed it before off to the side, we did one period from 0 to 2 pi. So we'll mark 2 pi and split it into 4 equal sections. And then we're going to think about where those 4 points end up going. Well, we had a point at 0, 0. Can you see that when you multiply that Y value by 2/3, it's going to stay at 0, 0? Same thing for this point, which is at pi comma 0. When you multiply your Y value by 2/3, it's not going to change. And same thing with this point, which was at 2 pi comma 0. When you multiply your Y value by 2/3, it's not going to change. But on our sine graph, we had pi over 2 comma 1. If we multiply our Y value by 2/3, can you see that now you're going to have pi over 2 comma 2/3. And same thing down here. You were at -1, now you're going to be at -2/3. So when we graph our sine graph for part A, our amplitude is now 2/3. So sort of a shortcut that we're going to be developing for graphing sine and cos is if we know that our amplitude is whatever that A value is, we can right away go from our center line and say, I'll go up 2/3 and I'll go down 2/3 from our center line. And since the center line of the sine graph starts at 0, that's what we're going to start with. For part B, cos of -4x again, we'll mark 2 pi, split it into 4 equal sections. And our amplitude for cos was 1, but with that 4 out in front, our amplitude's now going to be 4. In fact, that -4 out in front is a vertical stretch and a vertical reflection. You would multiply your Y values by -4. So it should make sense that since we originally had this point on our cos graph, pi over 2 comma 0, when you multiply that 0 by -4, it's going to stay the same. Same thing with 3 pi over 2. That's going to stay the same. Now, our cos graph normally starts at 1 at a maximum. What's going to happen when you multiply that 1 by -4? Now, instead of starting at a maximum, it's going to start at a minimum. And at pi, you had your cos graph at -1, but when you multiply by a -4, it goes up to 4. And at 2 pi, it's going to be back at -4. So one of the things you're going to start to realize is once you've separated something into 4 equal sections, and you find out where it starts, now it's starting at a minimum. It goes from minimum to middle to maximum to middle to minimum. And it alternates between that in each of those 4 sections. Now, even though the a value was a -4, when we say what the amplitude is, because remember the definition of the amplitude is the distance from the center line to a maximum or the distance from the center line to a minimum, well, that distance is 4. So we would still say that our amplitude is a +4, even though there's a -4 out in front. Okay, the questions you can do for this one are 3a and b, 4, 5, and 9.